Okay, welcome again. So we discussed the mini research and the due date and how you should do it, the expectation, the details are on the e-learning. We also talked about how you come to class. I'm not going to be sending any more links through the notifications anymore. The link is permanent over there in the e-learning. Starting Tuesday, you're going to start with Engineer Jawad to learn about the simulator. Today, we're going to continue two practical examples using C with microC Pro. The first example we started last time, we will use the microcontroller. We did not write any C program yet. So our first C program, okay, will be to make the microcontroller 16F877A MCU configure port B 0, port B1, port B2, port B3 as input ports. Okay. Then port B4 output, 5, 6, 7 output. Okay. We're not going to use the first three. First three are input for this for the first example. We're going to have LEDs here on the last four. Okay. And we will have port C and C0, 1, 2, 3, 4, 5, 6, 7 all configured as output. تمام. كلهم عليهم LEDs. Okay, we're gonna write a C program to make this blink in a pattern. مثلا every half a second, well, almost close to half a second, you blink this one on, off, and these four on, off, but acts when these are on, these are off, when these are off, these are on. Okay. Then in part 2, we'll add a push button and a motor. So let's go to microC and open our program from last time, our project, and continue it. It is starting, but you cannot see my desktop, unfortunately. When it's fully open, I'll share it with you. You don't see it, right?
Yes.
Okay. Yes. Now you see it. Microelectronica.
Yes.
Right. Okay, so I'm gonna open the project we started last time. Open project. I'm not sure if you see this dialog box, but class demo 4, C program, blink, open. And this is what we started last time, if you remember. Well, it's not there. This is what you saw last time. Sometimes I play with things afterwards. So we decided to set port B as output. Port B, half of the lower 4 bits as input and the higher 4 bits as output. So we went to bank 1 by setting bit number 5 in the status register. Status register by ORing it with a 1 and ORing every other bit with all the other bits with 0. So it will set only bit number 5. So we go to bank 1. Bank 1, we have the direction registers TRISB and TRISC. A 1 in the direction register is an input, a 0 is an output. So for the first 4 bits for the port B, we made it input. For the highest 4 bits, we made them output. For port C, we set all the 8 bits as output. Then we went back to and ANDed the status register with zeros, except for bit number 5 with a 1. You remember where we got this D0 from, right? If you don't, go to the recording of last time and you see how we got it. Okay, it is 8 bits, ANDing 8 bits with all ones except bit number 5 with a 0. That will make bit number 5 become a 0. So we are at bank 0 again. طيب, when we were dealing with assembly, when we used status, we had to write something up there, a directive called status equates address tree, right? Why don't we do this here? Well, the answer is because this development environment has it for us. So if you go right click on status register or TRISB, just right click on it and say go to find declaration, See, you will find something here written in a file in the libraries, the file called P16F877A.c that is included in our project, because when we selected the project microcontroller 77A, so it went automatically and included this file that has all this SFRs, the special function registers, and unsigned, it defines this something called status as an unsigned short volatile absolute at address tree. This is address tree in the data memory. Okay, so whenever you say status, it's going to be the compiler will know it is an absolute address at memory location 3. And these are the rest of the locations. So timer 0 is 1, PCL is 2. What else did we look at? Port B, for example, port B was 6, right? Port B and TRISB, but in the other, see, TRISB is address 86, which is, so even if we did not change the bank, the library would do it for us, okay? Because it sets the 8th bit, which is the bank select bit, to 1, okay? TRISB, and it should be here somewhere, the other registers, okay? You need to look for them or just search. Okay, and there are even more stuff, yani, okay, Control F, port B, see, port B, bits. So port B dot bit 0, port B dot bit 6. So your colleagues, I see them a lot in the lab just using these things. Port B, if they want to check if port B bit 5 is turned on, they just say if port B dot bit 5 equals 1. And okay. And when you ask them, okay, it doesn't hurt to use these things at a later level, but at this point, when you ask them, what does dot bit 7 do? Yani, can you write an equivalent line of code that would replace this? They don't know. They don't know. So that's why I'm not allowing you to use these libraries, okay, for the things we cover. So, yani, you could have said here, we could have said status dot bit 5 equals 1 or 0, and that's it, without doing this and or. But for the purposes of learning, we have to do it this way here. طيب. So we set all the port directions. Now we want to start our main loop. Okay, we are in the main function. We want to to start blinking, I want to turn the ports on, then turn them off, right? So we can, before starting the loop, we could do something, an initial values. So maybe port B, initially it could be turned off, maybe. Or port C, initially turned on, the LEDs. Okay, so all bits off. I'm talking about the LEDs connected to the pins, right? Or initially. And here, all bits initially on. Okay. طيب, port B, all bits are off. Well, I thought, the first 4 bits are input. Well, because they're input, even if we try to write on them, it's not going to work because there is a tri-state buffer that is disconnecting, right? So we cannot write. If you go back to the ports in chapter 3, you'll remember that. If a port is configured as an input and you try to write to it, it's not going to allow you. Okay. So initially the ports C is off, B is off, C is on. Then we do an infinite loop while 1. Okay, what does this mean? While 1 is true, right? So this condition is always true. So this loop is gonna be true forever. So everything inside it will be executed over and over again. Okay, so this is our infinite loop in this program. This is what we initially configure the directions, give the initial values, then we start doing things forever. Read the temperature sensor. Is the temperature sensor lower or higher than the set point I want? Then turn on the AC or turn it off, right? And then read the temperature sensor again. So we keep doing this forever. Okay. What do we want to keep doing forever? Let's write the comments. I want to blink port B, then blink port C, right? Blink in it has an initial value. I need to, whatever is on, I make it off. Whatever is off, I make it on, right? Then I do a delay. And then خلاص برجع blink again after the delay, right? So blink port B, I can do something like this. Port B, بقدر أقول له, okay, if port B equals 0, make it FF. If it's FF, make it 0. But there is something easier. You can say port B equals tilde, not port B, right? This is like the one's complement. This is like the complement instruction in assembly. This tilde. I imagine in studied C, you got to know about it. Then we also flip all the bits. Port C equals not or invert port C. Is everything okay?
Yes.
Yes, Dr. Tamam.
Last time there was a bad internet experience in the last 3 minutes. I find the kids turned on so I told them not to do it again. Okay. So putting this line of port B would become FF, port C would become 0, 0. Then we delay. Now there are delay functions, okay? But I don't want to use the libraries now. We want to be able to do our own delays. Do just some estimate delay now. After we start with the interrupts, we will be able to do very accurate delays. Since we're not writing a standard, we don't going to be converted into, how many instructions, so we can compute, okay? For the purpose, later on, interrupts, we're going to be able to calculate very, very. You still see my screen?
Yes.
Yes. Yes, doctor.
Okay. Okay, I got control back. Okay, I resumed recording. Is it still clear or واضح?
تمام.
كويس.
Okay, let me know if you have any issues. The issue is with Zoom itself. I believe it's with Zoom. Okay. So we're going to do a delay here by wasting time. So when you write a function in C, you need to do a prototype for it before the main function, right? So I'm going to do a prototype called void my delay. I'm not going to pass anything now, right? And then I write the function down here after the main function. And in here, I just want to waste time. Okay, I want to put two loops, for loops together, nested, just to wait time. So I need two counters. I'll use an integer I, and I'll use an integer j. And I know that I can write them in the same line, but I'm doing this on purpose for a reason. Then I say for I equals 0, I is less than maybe 50, I plus plus, then repeat this 50 times for j equals 0, j less than 2000, oops, j less than 2000, and this just numbers trial, okay, trial and error. We'll be more precise next time when we learn about interrupts, j plus plus. Then inside this 2000 times loop, just do I equals I, just waste an instruction, and j equals j, just like a no instruction, okay, just delay, waste time. Okay, so this will just waste time. It would write memory location I and memory location j 2000 times, then it will repeat this 50 times again, okay? Now the question here, we're designing embedded systems. For j, I understand that it should be an integer, because an integer, we talked about this last time, right? An integer in C, in this microcontroller, will reserve 2 memory locations, which means 16-bit, okay? 16-bit can hold up to a number from 0 to 65,536, okay? So while I is just holding a number up to 50, so I cannot, I don't need to book or reserve 2 memory locations. 1 memory location will do it. So if I say unsigned character, a character here is 8-bit. When it's unsigned, so I'm using the whole 8 bits for I. So when you have 8 bits, I can be any number from 0 to 255, FF, right? 8 ones, 255. So 50 is lower than 255, doesn't matter. So if my I counter is anything below 255, I can just book 1 memory location. This is only 1 memory location. Oops. Okay, what am I doing? 1 memory location. While the j, because it's an integer, 2 memory locations. Okay, يعني one memory location 8 bit. هذه 16 bit. Okay, so I'm just wasting time, and we're done. Every time, just come here, flip the pins, the bits in port B, flip the bits in port C, waste some time, call this function, waste some time, go back forever. Just keep doing this forever. Let's program this on our microcontroller and see how it works. I'm gonna turn on the microcontroller and program it. Okay. I just hit under build and program. Build and program. It's going to start programming. High speed, disable, everything is set, right? And it's programming. You don't have to do anything. Programming. And now I'm going to go turn my camera to, I'm going to stop sharing and turn my camera. Stop sharing. Where's Zoom? Okay, stop sharing. Stop sharing, stop sharing. And then turn the camera to the USB camera. Do you see anything? I see a frozen thing. Guys?
Victor, your picture is frozen.
Anna, frozen. What happened? Many things, weird things happen. Okay.
دكتور أظن الابلكيشن صار كثير يعلق.
صح, the Zoom thing. And now I'm back.
لأنه كثير ناس بيحكوا إنه في صار يعلق كثير صار فيه مشاكل.
Yes, Zoom is having issues. Zoom is having issues. That camera is okay. I'm back to recording. Thing causing it not to. So here, do you see? Okay. Here's the board. You see the board? See the LEDs blinking? Top. B, C, B, C.
واضحين دكتور.
Yes, دكتور واضحين.
Okay, شفتوهم okay. Not so convenient, but most likely I'm not going to share this video with on publicly. It's فيها مشاكل كثير صح? If anybody has issues, can ask again. طيب. So this is the first program. والوقت خلص. وأنا مجهز الموتور هيو. You know, انتوا installed خليت الأولاد حطوا لي عليه لزقة حمراء عشان تشوفوه يلف. يبين معكم يلف. سامعين صوته؟
Yes, دكتور واضح.
Do the interfaces. I got a PMOS transistor here, okay, and we'll do a circuit controller. ليش PMOS؟ لأنه I cannot give it power directly from the microcontroller. بدي أستخدم battery high, okay, و I need to أوصل وأقطع عنه الكهرباء, okay, بعد ما I read the push button if it's on or off. I expected to do more in this class. So most likely, Mohandas Jawad, you're not going to have the full class next time. You may have half of it and the rest of Thursday's class. I'm stopping to record.
دكتور احنا بنخلي البداية